Welcome. If you are joining us for the Autodesk Design and Make Educator webinar series, you are in the right place, and we are super happy you're here. My name is Kellyanne Mahoney. I'm here filling in for your trusty host, Jason, who will be back for the next webinar on the 23rd. But we are super excited that you're here. This is going to be an intergalactic journey from Tinkercad into other planets such as Mars. We're going to be talking about architecture and construction and ways to share skills with your students onto those career paths, beginning with Tinkercad. So as we're getting started, please warm up the chat. We want this to be a multiplayer conversation. So do please let others know which careers are your students most interested in pursuing. Do you have a lot of future YouTubers out there? Do they want to be astronauts? Do they want to be architects? So please let us know in the chat. Also, feel free to say hello to each other. We have a beautiful global education community that is part of the Autodesk family. So we're super excited you're here. And do please say hello to each other. Anything happening in the chat so far, Randy?
There are a lot of people saying hello.
Well, that's wonderful too.
It seems to be from all over: New York City, Morocco, Detroit.
Wow, so cool. Never gets old.
So it seems like there's students interested in pursuing engineering, robotics, various technology fields, gamers, artists, athletes, engineering, more engineering, mechanical engineering. Let's see what else we got here. Technology and architecture. So this is a good webinar for you because today's all about that. And yeah, let's see. Drones, coding, electrician, and then yeah, we have students interested in automotive and industrial design. So it's like kind of really a wide array of fields I'm seeing here. A lot in engineering, but it's kind of all over.
Cool. All right, so we're going to get started with the webinar. So super glad you're here. Randy, thank you for being our trusted chat vocalist as we get into the topic of the series. So this is the Autodesk Design and Make webinar series for educators. And this webinar is on the topic of building digital skills for architecture and construction. So my name is Kellyanne Mahoney. I'm a youth programs manager for Autodesk, and I am here filling in for Jason, who will be back for the next webinar, but super excited to be here. Also wanted to introduce our chat captain, co-host of the night, Randy. You want to say hello?
Hi, I'm Randy. I'm on the Autodesk student community team, and I primarily focus on Tinkercad and Instructables, and I'm happy to be here and kind of help out with this webinar.
And I'm happy you're here, Randy. We are also super happy that Max Pommier, who is a senior designer for the Aurelia Institute, is here to talk to us about architecture in space. So please stick around for his presentation. We also will be having one more of these webinars. So the next topic is design and make anything. We also are going to have a special guest who is the quarterback for a quarterback for the 49ers. Joshua Dobbs is going to be joining us to talk to our community of educators. So we'll share more context about that later. How to participate. You're already doing a great job. So do please keep connecting with one another in the chat. And also, if you have questions that you want to have answered in real time by the Tinkercad team, please use the question and answer tool. That will help you out. Before we begin, we just want to get to know you a little bit better. So Randy is going to be launching a poll. So the poll is, what subject and grades do you teach? You can choose more than one answer. So you can say science and middle school. You can say art and high school. Looks like we have a wide variety of educators here this evening, which is great. Seeing a lot of middle school, which is a sweet spot for Tinkercad. Lots of technology. And we'll close this out in a second or two. All right, should we end the poll, Randy? All right. So again, this is the Autodesk Design and Make Educator series. We are going to be talking about how you can empower your students to design and make anything. And today we're going to be shifting a little bit in our focus to talk more about architecture and construction. So in thinking about Autodesk, so we are a software company. We make software for people who make things. So our customers make things in a variety of different outcomes. So Fusion is a platform that you've been introduced to through this webinar series. And when our customers are using Fusion, they're designing for the design and manufacturing and assembly industry. So they might be designing things like robots, like cars, like architecture for space. So that's Fusion. Flow is another platform from Autodesk that is more geared towards the media and entertainment industry. So, things like the computer graphics in video games or in movies. And then lastly, Forma is for architecture, engineering, and construction. And we're going to talk a little bit about those industries today. In terms of some of the tools that we'll be introducing to you today, you can find all of those on the Autodesk Education community. This is where you can go to unlock education access to about, I think it's over 60 tools for free at this point. So in thinking about what's the purpose of our technology, one of the things that we really thrive on at Autodesk is thinking about how we can enhance the collaboration across teams from the top floor to the shop floor. All the data is being integrated and shared with one another, from the design into the make, whether it be a building or whether it be a train. In thinking about this workflow in construction, this is kind of how it's laid out. So thinking about the different phases of construction, there's design, plan, build, and then operate. I know it seems weird to think design and plan, or design comes before plan, but those two phases kind of interact with one another. So when we think design, it's kind of like sketching, concept, plan. In the construction industry is more kind of thinking about coordinating systems within a building and also thinking about how the building operates on the specific site where it is. And you can get your students starting to think about careers in these industries through using Tinkercad. So they might design something architecturally in Tinkercad, like a dream house or a dream room. In Tinkercad, they might also even use code and computational thinking to create, some of the features of the building, like steps. And this is an adjustable set of stairs that you could make in Tinkercad code blocks. And one of the reasons why we put that in Tinkercad is so that, in the future, your students might be using, something like Dynamo, which is a kind of visual coding language to do generative design for the architecture industry. Not only can you use a script from Dynamo to make stairs as an architect, but you could also even follow that sketch of the stairs to create a rail for your stairs. So there's all types of cool things that you can do in combining coding and architecture that students might find really interesting. You could also design something like a bridge in Tinkercad. When we say AEC, we're talking about architecture, engineering, and construction. The engineering in the construction industry is a lot of times it's kind of focused on civil engineering. There's also geotechnical engineering. There's MEP, so when you're designing HVAC systems. In Tinkercad, you could take your bridge and put it in a real life, location that you've designed. You could also even think about the plan for the city, like the urban planning, thinking about a grid pattern that you could make in code in Tinkercad. But then, when your students move on in their careers and level up in their design skills, they might move on to a platform like Forma, and they might bring their building into a real location using that publicly accessible geographic data. They could do energy analysis, a heat analysis on the building, the solar gain, even thinking about things like wind and noise. And then they might even work on a project when they're in college where students are designing different buildings in the same immersive kind of cityscape together, kind of like how they're playing in Roblox now. One of the things that I love about architecture, engineering, and construction is the emphasis is ultimately you're going to actually build a thing. So this involves also the trades. So students that are in vocational trades programs, so they might be in a carpentry program, and they might have an assignment to build a piece of furniture using one board. And they might do that, in Tinkercad, kind of planning it out. Electricians could also use Tinkercad to think about, when you're introducing electrical concepts to students, such as Ohm's law. You might also introduce students to kind of the concept of like designing HVAC and ductwork in Tinkercad. And then once they get into a program like Revit, for example, they can actually then think about the insides of a building. So the plumbing, the electrical, the ventilation systems, which is kind of like putting together like puzzle pieces for students that are kind of into that sort of thing. And then, they might bring it into, another software program like Autodesk Construction Cloud, for example, to think about like how you might navigate those systems and detect clashes between electrical and plumbing systems. And also just like in thinking about, some of the things that students could design in Tinkercad, really it's you're starting out with building blocks, just like, when students are learning spatial reasoning and, or even when they're not students, when they're little babies playing around with blocks. In kits, they might move on to familiar plastic bricks. Within Tinkercad, you can actually quantify your design and think about how many pieces that you would need to build it, which is a skill in construction. So there's all types of construction math that students could learn using Tinkercad. They might also, even if they're designing a playground, you might add a layer about safety, and maybe bring in some, rules or regulations around safety, which is super important to the construction industry. And then again, using a tool like Autodesk Construction Cloud, when students get older, they might be able to think about like how they could go from 2D to 3D, thinking about scheduling work and, even like quantifying, like this is how you would quantify the parts of a building in Autodesk Construction Cloud, where you can start thinking about estimating how much the cost of a building would be to construct it. So that's just like a quick overview of some of the things that students could design and make using the tools that are offered by the Autodesk education community. We do have these cool lesson plans in Tinkercad if you go into resources on Tinkercad. And I've just outlined a few of them that I think, definitely teach skills that are applicable to architecture, engineering, and construction. There's also some cool projects on Tinkercad. So Jason made this really cool redesign of room. So as you can see here, Jason had his students doing all types of mathematical reasoning and, thinking about the dimensions of the room and, calculating measurements and also thinking about how you go from a 2D blueprint into a 3D design and even thinking about how to building out a physical prototype of the model. Another cool example is this rose window project that was created by a teacher. This emphasizes the code blocks environment within Tinkercad. It's a really cool way to introduce students to the intersection of computer science and computational thinking with the field of architecture through creating this really interesting and beautiful ornamentation for a building. I did also want to talk to you a little bit about the Make It Real program that I manage for Autodesk that is meant to be a way to introduce careers in architecture, engineering, and construction to students specifically. And we are super excited that our spokesperson for the program this year is Josh Dobbs, who is an NFL quarterback. He actually just recently joined the 49ers for the upcoming season, so we'll be rooting for him in the upcoming season. But for now, he also, one thing that it makes Josh super interesting is he studied aerospace engineering prior to joining the NFL, and he even interns with NASA in the off season. So how cool is that? And one of the ways that we partner with these professional athletes to inspire students is to help guide them through questions that they might have in choosing what career path they might want to pursue. And what we love about young people today is they really want to find meaning and purpose in the careers that they pursue. And we like to show them that architecture, engineering, and construction is one way of doing that. So we actually brought Josh to one of our customer sites in Phoenix, Arizona, Knox Innovations, which is an awesome company that they actually work on a lot of their projects. They're big data centers for technology companies in the desert. So they not only design some of the electrical conduit and some of like the structural components of these buildings, they also fabricate those components in-house. So they really go from design to fabrication all in one place. So we thought this would be an interesting place to bring Josh to explore his interest in how building for the extreme environment of the desert could also be an analogy for thinking about how we might do that in the future on other planets. So it was a really fun story to do with Josh. He meets with the president of Knox Innovations. He meets with a fabrication worker. He also meets with a virtual construction manager. So this is one way that we also try to introduce different types of careers that students might be interested in this industry. And you can find out more information about the program at the Autodesk.com Make It Real webpage. So here's just a sneak peek of one of the films that we did with Josh.
Football fans, they know me as Josh Dobbs, starting NFL quarterback. My journey on the field has also been accompanied with my journey off the field as an aerospace engineer and NASA intern. Today, I'm embarking on a new story. I want to flex my mind in new ways to be a force for change. Join me as I travel to the desert to see firsthand how builders are executing designs, gleaning lessons about resilience with astronomical implications.
So students, the future needs you. So please spread the word to your students. So one of the ways that this program aims to inspire students is through the Make It Resilient Student Design Contest, which is currently hosted on Instructables. So this is a contest for students in the United States, ages 13 to 21, and also in Canada, so the United States and Canada. We offer over $50,000 in prizes. There are 2 $10,000 scholarship awards, 4 $5,000 scholarship awards, and 10 $1,000 scholarship awards. And you can see a little preview also both in the film and also in the on the contest page of this really cool TESSERAE pavilion that Max is going to talk to you about this evening, which provided the starter model for students who are interested in entering the contest. The prompt is, what if extreme environment habitats embrace their unique surroundings to enhance human well-being? So thinking about how to build habitat in space or in other kind of extreme environments. So we'll talk about that a little bit later as well. But as you can see in the bottom of the screen, the Aurelia Institute used Autodesk Fusion as part of their process. And then this model we put in Tinkercad for students to help them get started. So here's where you can go to learn more information about the whole program. So you can find the films with Josh on the Autodesk.com Make It Real page. You can also see some of the films we made previously with other awesome athletes who are interested in STEM. So Connor Clifton from the Bruins and James Devlin, who we worked with for many years, 3-time Super Bowl champion. You can also find more information about the scholarship award. There's a direct button that takes you to the contest page on Instructables. In addition, there are also some technology tutorials that introduce students to the AEC collection of tools that are accessible to them through the Autodesk education community. And this is also a place where you can go. So in addition to the $50,000 scholarship awards, the Make It Real program also has a component that is $50,000 in micro grants. So these are $500 micro grants, specifically targeting students ages 17 to 21 in the United States who are interested in pursuing careers in the building trades. So if they want to be a plumber or a carpenter, an electrician, all the other awesome trade opportunities that students have. So we've been doing this program for several years. We always try to start with an inspiring prompt. So in 2022, for example, it was a shipping container. And the prompt was, what if a structure could meet a need in your community now, but could also be repurposed later? And just wanted to share with you just some examples of what students can do when they're empowered with Autodesk tools in order to reimagine, what the built environment could be. So for example, you can see the student in the upper left-hand corner was a student who's actually in the Baltimore area in the United States, and there was a bike path in his community that he felt like wasn't being as utilized as much as it should be. It was really cool, but at night, there was not a lot of activity on the bike path. So his idea was to repurpose a shipping container into a bike repair shop that's a cafe on the bike path. So that was super cool. Another student on the right-hand side, Michael Hidalgo, he designed this affordable housing out of a shipping container in order to think about the unhoused community that he was seeing when he was living in Miami and seeing on his way to school in the morning. And he not only did a really cool CAD model, he also created a physical prototype, which is what he won for that year. So students really kind of showed us, in many different ways and different modalities, how they are envisioning, the future of the built environment. So, how they could create exploded views, or how they could include interesting animations to kind of show their process, and also to kind of think about how this concept of modular design could be applied in order to, have better outcomes for the environment, to make building more efficient and more affordable, and also, to reduce cost as well. Last year, our design prompt was, what if bridges were more than physical connectors? And we were inspired actually by another really cool project that was happening in the Autodesk Technology Center in Boston. So in 2023, we gave away $100,000 in scholarship awards and micro grants to students. So this empowered 136 young people on the path to construction-related careers. 56% of these recipients plan to enter the building trades directly from high school. So, part of the Make It Real program, half of it is this $50,000 scholarship awards through this contest hosted on Instructables. In addition, if you know students, this is just strictly for the United States, who are between the ages of 17 and 22 and are thinking about transitioning into careers in the building trades. We are offering $500 micro grants for that. And we do really try to, in our promotion, try to reach schools that are under-resourced in different ways. And we feel like we've achieved that through the program. Here's a link, actually. So every year we also capture the students' stories, and they're very inspirational. So here's a link to a blog post, so you can read some of the student stories who've benefited from this contest. It might be interesting for students to read as well. So again, through this program, we try to inspire, particularly because the focus is on construction. We want to raise awareness about the convergence of design and construction. And it's always just interesting too to see like how students kind of really think outside the box in terms of like, what is a bridge? So this was an example from a student, and you could see his little sketch at the beginning. We love that when students kind of show how they start out and how their project evolves and iterates. This was a public park that a student designed. This was using Revit. Another student, this was a student up in Calgary, Canada. She wanted to think of a bridge as a metaphor, also as like connecting the local history in her community, the Native American history, to modern day. So the bridge was almost like it was a pedestrian bridge, but it was also a teaching tool. And she incorporated Native American motifs and symbols of the tribe that was native to her area. This was a student whose grandparents were in the Philippines, and he was visiting his grandparents during the summer. And it was interesting where the agricultural land was. They were experiencing extremes of flooding and also drought. So this was a design that he made in Fusion 360, in which he was thinking about how a bridge could also be an irrigation tool. So it could be a bridge when there's flooding, but then it also could capture water and irrigate during times of drought. Could a bridge be a boat? The student thought so, and I thought it looked pretty cool. Also, and again, that we really want to elevate the idea of making things, and even making things with your hands and making physical prototypes. So this was a student who won best physical prototype. One student actually made a real bridge. So she built a real bridge in her grandparents' yard. So that was super cool. So just some examples of student work. This student used both Revit and Fusion 3 and Autodesk Fusion. This is another cool Revit example of a walkthrough of his design. So this year, again, the prompt was inspired by the Aurelia Institute's project that Max just described, and is what if extreme environment habitats embrace their unique surroundings to enhance human well-being? So in thinking about how can we get more students started and engaged, and even if they're too young for the contest, how can they, engage in this cool concept inspired by the TESSERAE Pavilion? So we did actually a series of Tinkercad challenges. One was on the Arctic. So this is the Arctic Habitat Challenge. And here's some examples of what students made from all over the world. And you can see that truncated icosahedron from the Aurelia Institute, that was the inspiration for these designs. The next one we did was on floating architecture and aquatic habitats. So you can see my silly design that I made, the penguin for scale. And then you can just see the way that students' imaginations were kind of unleashed in thinking about like how you can be creative within constraints and that concept of resilience. And currently, right now, our challenge is the Desert Habitat Challenge. So this is an example of, this is like a golf kind of clubhouse that's in Jordan. And as you can see, similar to when Max was talking about biophilic design and kind of that idea of bringing nature kind of inside and kind of have it reflected even in the exterior of buildings, how that can, enhance, the well-being of those who are living in it. So this was a design that was inspired by the sand dunes in Jordan and in the desert, extreme temperatures, going from really hot to, the temperature actually getting cold in some parts, the lack of traditional infrastructure, and also wind is a huge issue in the desert. So thinking about how you can use nature that is native to, the place that you are building, using even in situ materials, can lend to really resilient designs. So this is my silly design from the Tinkercad Desert Challenge. I found inspiration in the design of a cactus, or in the beauty of a cactus, and I implemented that in my design. And I wanted to show you just a little quick demonstration in Tinkercad of how you can even play around now. This challenge closes on, I believe, Monday or Tuesday of this week. So you still have a few more days to enter. And hidden within the challenge, there's actually a really cool adjustable kind of parametric design. So in Tinkercad, you find the challenges under resources. Here's the Desert Habitat Challenge, still open, lots of really cool submissions as well. So I'm going to click copy and tinker. Here's our starter model, which is also the same starter model as the contest this year. But within the text, there's also this cool remixable. It's a decahedron that is made in code blocks. So at the top, there is a variable, which is the inverse of the tangent. And I decided to play around with that. I also played around with the shape. So instead of a box, I turned it into a cylinder. And just by playing around with just some of the variables and also just kind of some of the other parts of the script, I was able to just iterate really quickly and make some interesting shapes and designs, and even an organic shape by making that round cylinder. So now I'm back in Tinkercad, and I'm going to delete the one that is solid, and I'm going to take the hollow one. And I've taken that actually both of these shapes that I've made in code blocks. I sent it as a part or as a shape and brought it into my shapes collection in Tinkercad. And I'm not trying to think about like floors and, the electrical, where the electrical is going to go in this. I'm just sketching. I'm thinking about concepts. I'm thinking about like the massing of the buildings. And I'll think about the details later. Within Tinkercad, there's also the scribble tool. Scribble is my favorite shape. And I went into scribble to make kind of a kidney shape, using the coloring tool and the pencil tool to fill in some of the dots. And then, I'm shrinking it down. I am changing the color. I was inspired by the kind of multi-layered sort of like rocky plateaus in the desert. So I thought that could be like a cool, you know, deck or a staircase for underneath my building. So then I'm using Smart Duplicate to just make minor adjustments. So changing the angle slightly, changing the size slightly, and just hitting Control D, Control D. I wanted to make the buildings go away for a moment, so I hit the light bulb to hide them. And now I'm just adjusting the colors a little bit. And then I bring my building back just by hitting the light bulb again. It's more of a campus now, and I'm rotating it. I had some cacti in my creations, so I decided to go in and use them. I decided to stretch out one of the cactuses. And then, oh, also, sometimes people are like, how do you make the sky blue? You can actually hide, if you go into the settings in Tinkercad, you can hide the grid, and you can also change, you know, the color of the background too, which is really fun. I know that teachers are very interested in, you know, what is the cutting edge research that's happening right now that's kind of influencing the future of work for our students. So this was a cool paper that actually Autodesk worked on with ASTM, in which they were mapping out advanced technologies for the digitalization of construction. So part of my job at Autodesk is to think about how we can get young people, how we can get educators, how we can get even parents interested in, you know, having their students think about careers in construction. And one of the really, I feel like, influential ways that we can do that is to talk about all the cool technologies that are starting to intersect with the future of construction, from the Internet of Things and sensors, augmented reality, robotics, you know, thinking about 3D printing buildings. And then some of the applications. So, you know, when we talk about tessellated electromagnetic self-assembling architecture for space, you think of it as something that's, you know, in the future, like, you know, at least like 20 or 30 years out, but it's something that's actually being thought about, as you could see from Max's presentation, and implemented now. And that's something that could really inspire some students, you know, who maybe want to be astronauts, but also, you know, might want to think about, you know, how those astronauts might be living, you know, in the future if they have to, you know, to be, you know, in a space with other humans and having a livable habitat. You know, and these are all other, you know, ways that you can inspire students who want to have purpose and meaning in the careers that they are interested in the future, be it, you know, maybe it's affordable housing is something that they care about, you know, maybe it is, you know, environmental sustainability. So now I would love to hand it over to Max so he can tell us more about the cool project he's working on with his team over at the Aurelia Institute, in which they are imagining what building off Earth might look like in the future. So please take it away, Max.
I'm happy to be here. Happy to be here with all of you from, it looks like, everywhere around the world, which is really impressive. I am representing Aurelia Institute. We are a nonprofit startup that spun out of the MIT Media Lab with a focus on building technologies, communities, and policies to connect Earth and space together. And we're a pretty multidisciplinary and cross-functional group of people, architects, engineers, designers, researchers, operations, and business-minded folks. My background specifically is in terrestrial architecture. I have experience building multifamily housing, train stations, schools, but I've always been a big sci-fi nerd and spent many a night looking up at the stars, wondering how we would, beyond the ISS, occupy the cosmos around us. I am based out of Boston, currently at the Autodesk Technology Center. We are residents here where we're able to build some of the large scale structures that you caught a glimpse of from the Tinkercad challenge that are representing the projects that I'll go into. We're also based remotely across a couple of different time zones, and we're very proud of our anchor here at Autodesk of having access to some pretty fantastic shops, printers, laser cutters, water jets, lathes, you name it, they're here. And it's helped us build a lot of the projects that I'll go on to talk about. So we have a three-pronged approach to our work. One, our R&D lab arm, we're focused on building the infrastructure to scale humanity's presence in space, from structures to interiors to systems, objects, and manufacturing processes. Our second arm is based on community. Our academy is a series of courses that we teach to democratize access to space, is the short of it. Basically bringing communities, groups of people who might not be traditionally represented in the space industry closer to the networks, to the opportunities that help build the next generation of space explorers. So we teach a course on microgravity project design, which culminates in a series of zero-G parabolic flights, 2 of which are happening next week. And we do this every year, and we're developing other courses on space architecture and technologies to develop spaceflight technology. So, and then the third arm, which is also just launched this year and is very interesting, is a Center on Ethics and Policy. And so this is about addressing the thorny questions of how the space commons are governed, how resources are considered, how we can approach the exploration of space in a more respectful way than we've done in the past, and how we treat the new technologies, the technologies that are at the vanguard of life on Earth, expanded out to space, including, of course, artificial intelligence. I'll focus just for now on our R&D projects, but I'm happy to field any questions and point you also to our website for more. The central concept that we are developing is called TESSERAE. It's a mouthful of a concept: the tessellated electromagnetic space structures for the exploration of reconfigurable adaptive environments. It's a modular idea of a space habitat composed of hexagon and pentagon tiles that can be flat packed into a standard rocket fairing, shipped out into low Earth orbit, and then there autonomously assemble and are pressurized to form a much larger volume than the traditional pressurized cylinders that form the ISS and past space habitats. We're building out this technology on a couple of different scales, one of which is these miniature tiles that you see here pictured in the ISS. They've flown twice already in 2020 and 2022 to test the system of magnets and mating algorithms that allow for this autonomous assembly in microgravity. And then we're currently building out the 5th generation of the tiles for a 3rd deployment on the ISS in 2025 at Autodesk with the help of, among other machines, Formlabs SLA printer to build the resin case that houses the electrical components, these guts right here. These are the electropermanent magnets and the solar panels that power them. And so in between the ISS deployments, we're able to test iterations on these parabolic flights. As I said, we're flying a couple next week. And so during the course of these flights, our team plus the students that we work with, we experience periods of microgravity between 17 and 20 seconds long each, and we're able to test some of the assembly features. This is our VP of Engineering, Annika, definitely not having fun. It's a pretty unique experience. And I'm flying my first one next week, so I'm stocking up on all of the anti-nausea medicine. The second part of our projects is Earthbound. It's a one-to-one representation of the TESSERAE concept of the interior to explore what types of atmospheres, technologies, experiences, materials we can prototype to support a more humanist, Earth-connected version of life in space, one that's not value engineered down to the bones, but rather is lush, is inspired by natural patterns, is basically much more comfortable for its inhabitants. So we've been able to design and build this modular system of this kit of parts at Autodesk that can be dismantled over the course of a day and a half, packed into crates and then shipped out pretty much anywhere. We're doing a soft launch in Boston this summer for the ISS Research and Development Conference, and then in Seattle in September at the Museum of Flight, and then we'll see. So one of these projects is our green vault. So it's this aeroponic garden to show the potential of growing plants, herbs, fruits, vegetables in a very low impact way, because we don't want to ship huge amounts of soil or even water. And it turns out that plants love droplets of water of around 50 microns. Their roots grow really bushy and fast. And so this is a developing concept, and a lot of it is still unformed, and that's why we're inviting collaborators, artists, designers, researchers to contribute to the interior of the pavilion for our next build in July. And then the third part of our R&D work is more visioning about what this concept, this module of TESSERAE might look like 30 years in the future. And so here we're working with structural engineer partners to test pressurization challenges, for example, with attitude control and determination systems, to put together a case study of how our concept lives in relation to other existing and planned habitats. This is a vision for the TESSERAE module acting as a home for 4 people over the course of 9 months, 2 of whom are scientists, researchers, 2 are astronauts, that will serve as a biotechnology research lab. And so this allows for experiments and manufacturing processes such as protein folding and advanced 3D printing that might be actually better, more precise, and ironically, or believe it or not, less expensive to do in microgravity, because the absence of a gravity vector allows for more for faster work. And so this concept that we're developing, the interior of, trying to negotiate how different spaces for work, for downtime, for sleep, exercise, all within this closed loop ecosystem live, and then down to how a workspace is laid out in microgravity. So we're conducting research with different scientists, researchers, to understand how they work on Earth and how experiments are run on the ISS, and then how we might propose a way in between the two of conducting scientific work. So we've already published one summary of our work, which you can find on our website here, and I'll point it at the end of my slides. And we're publishing an update in September. I believe I've reached the end of my introduction, so I'd love for people to stay in touch, ask any questions, and we're, again, very excited by the possibility of branching out this concept, this shape, and then the research into extreme environments, and seeing that filtered through the minds of many, many students around the world.
So thank you so much, Max. That was so inspiring. I knew it would be. And we went all the way from Tinkercad into Mars. So what a great journey that we've all been on together. Thank you, teachers, for hanging in there. You will, if you've joined live, will earn a certificate for 1 hour of professional development. So please check out your inboxes to make sure you get that certificate. Just, some heads up about some fun contests that are happening right now. We've extended the deadline for the Green Future Student design challenge so that it closes on June 3rd. This is a contest in which students are encouraged to use Fusion 360 or Autodesk Fusion, sorry. Engineering in the Kitchen, which is another one, closes on June 3rd. Made with AI. Remake It, which is kind of thinking about, taking something like, a chair, for example, and thinking about how you might reimagine it to, suit users in a better way. And last but not least, the Make It Resilient Student Design Contest. So offering $50,000 in prizes. It's open to students in the United States and Canada, ages 13 to 21, and it closes on June 24th. So we encourage you to at least check it out. And do know that our next webinar is on the theme of design and make anything. We will be joined by Josh Dobbs, who is a quarterback for the 49ers. He was a starting NFL quarterback this past season, most recently with the Vikings. Cool fun fact about Josh is he interns at NASA in the off season. And this is one of the reasons why we thought he would be a great spokesperson for our contest, given his background in aerospace engineering. So do please join us for that next webinar.